Hello everyone, my name is Anjanette Cash. I am a doctoral student at the California Intercontinental University. Today I will be presenting Conducting a Simple Regression. Let's take a look at our agenda today. We will first go over the variables used in our three example regression tests. We will take a look at some takeaways. And last, I will take any questions you may have. Variables used in our hypothesis test. The first regression test, we're going to find out, can we predict the individual's debt by knowing their income? The dependent variable used is debt. The independent variable used is income. The second test, can we predict the increase in an individual's saving by the increase of income? The dependent variable here is savings, and the independent variable is income. The last test, can we predict the increase in an individual's portfolio value by the increase of their savings? The dependent variable here is stocks, and the independent variable is savings. Here's our first regression test. The following regression was conducted for debt and income. Our null hypothesis states the regression coefficient beta is 0. Our alternative hypothesis states the regression coefficient beta is non-zero. A simple linear regression was conducted to predict an individual's debt by knowing their income. No significant regression was found. By the results of beta equals minus 0.05, r squared equals 0.00, and the p-value equals 0.532. Here's our second hypothesis test. The following regression was conducted on savings and income. Our null hypothesis states the regression coefficient is 0. Our alternative hypothesis states the regression coefficient is non-zero. A simple linear regression was conducted to predict will there be an increase of an individual's savings if there is an increase of their income. A statistical significant regression emerged. The beta equals 0.91, the r squared equals 0.82, and the p-value equals 0.000. Thus, the test rejected the null hypothesis and predicted a savings. Savings is predicted to increase as income increase. Further, the 95% confidence interval does not contain 0, hence lending support to the prediction. Our last test, the following regression was conducted on savings and stocks. The null hypothesis states the regression coefficient is 0. The alternative hypothesis states the regression coefficient is non-zero. A simple linear regression was conducted to predict that if there is an increase of an individual's portfolio value, will there be an increase in their savings? A statistical significant regression emerged. Beta equals 0.28, r squared equals 0.07, and p-value equals 0.000. Thus, the test rejected the null hypothesis and predicted savings. The stock is predicted to increase as savings increase. Further, the 95% confident interval does not contain 0, hence lending support to the prediction. Here are some takeaways from today's presentation. R squared is always between 0 and 100%. One way to express the hypotheses for regression is, for the null hypothesis, the slope of the regression is 0. For the alternative hypothesis, the slope of the regression is non-zero. As we define our hypothesis test, the dependent variable is what we predict, and the independent variable is the regressor. This concludes the presentation. I would like to thank you for watching. Please use the comment box for any questions you may have. Again, thank you.